Question 13 is on quadratics, and we have got the path of a ball which has been thrown and can be modelled using the quadratic curve y equals 3 plus 4x minus x squared, where x represents the horizontal distance the ball is thrown and y represents the height of the ball above the ground. We are asked to write down, so again, remember, write down means it should be fairly straightforward, to write down the height in meters from which the ball is thrown. Now, if you think about it, at the initial point here, the ball has not actually travelled any horizontal distance. So x represents the horizontal distance, so that will be 0. So in the equation, you'll just be left with 3 plus 4 times 0 minus 0 squared. So that is just going to be 3 meters. For part B, there are a number of different approaches you could take. Probably the most simple is just to graph it. So on your GDC, you're going to enter y equals 3 plus 4x minus x squared. Second, calc and find the maximum, and that will give you the x coordinate and the y coordinate, which is what you want. So that will give you 2, 7, and it's the height you're after, so that is going to be 7 meters. The other way you could do it is using calculus. So if your function is y equals 3 plus 4x minus x squared, if you differentiate that, your gradient function is going to be 4 minus 2x. And we know that at the maximum here, the gradient will equal to 0. So 4 minus 2x is equal to 0. So therefore x equals 2. We've been asked to find the maximum height. So we want to find the height when x equals 2. So you substitute 2 into this equation, and you will end up with y equals 3 plus 4 times 2 minus 2 squared, which also equals 7 meters. Indeed, the other way you could do it is using the formula for the line of symmetry. So x equals minus b over 2a. So remember, when we have a quadratic, we have ax squared plus bx plus c. So looking at our equation here, we can see that the coefficient of x squared is going to be a, which is minus 1. Coefficient as b is going to be 4, and c is just going to be 3. So if we substitute that in, we're going to have minus b is going to be minus 4 over 2 times minus 1. So that is also going to give us 2. And again, similarly, we're going to just substitute 2 into this equation, which is also going to give us 7 meters. In part C, we're asked to find the horizontal distance from the base of the wall to the point at which the ball hits the ground. So that is, in effect, the distance here. So this is essentially asking us to identify the x-intercept. So we can do that by solving this equation. So what we're trying to effectively solve then is 3 plus 4x minus x squared, which is the quadratic function for this curve, is equal to 0. And the easiest way to do that is just using the polysmol function on your GDC, and that will give you two solutions: a negative one, which is going to be over here somewhere, which we can ignore, and the positive one, which will be x equals 4.64575, or just 4.65 meters, correct to 3 significant figures.